Sonar, which is an acronym for sound navigation and ranging or sonic navigation and ranging, is a technique that uses sound propagation usually underwater, as in submarine navigation, to navigate, measure distances using ranging, communicate with or detect objects on or under the surface of the water, such as other vessels. Sonar can refer to one of two types of technology. Passive sonar means listening for the sound made by vessels. Active sonar means emitting pulses of sounds and listening for echoes. Sonar may be used as a means of acoustic location and of measurement of the echo characteristics of targets in the water. Acoustic location in air was used before the introduction of radar. Sonar may also be used for robot navigation, and SODAR, and upward-looking in-air sonar, is used for atmospheric investigations. The term sonar is also used for the equipment used to generate and receive the sound. The acoustic frequencies used in sonar systems vary from very low, infrasonic, to extremely high ultrasonic. The study of underwater sound is known as underwater acoustics or hydroacoustics. The first recorded use of the technique was in 1490 by Leonardo da Vinci, who used a tube inserted into the water to detect vessels by ear. It was developed during World War I to counter the growing threat of submarine warfare, with an operational passive sonar system in use by 1918. Modern active sonar systems use an acoustic transducer to generate a sound wave which is reflected from target objects. History. Although some animals, dolphins, bats, some shrews, and others, have used sound for communication and object detection for millions of years, use by humans in the water was initially recorded by Leonardo da Vinci in 1490. A tube inserted into the water was said to be used to detect vessels by placing an ear to the tube. In the late 19th century, an underwater bell was used as an ancillary to lighthouses or lightships to provide warning of hazards. The use of sound to echolocate underwater in the same way as bats use sound for aerial navigation seems to have been prompted by the Titanic disaster of 1912. The world's first patent for an underwater echo-ranging device was filed at the British Patent Office by English meteorologist Lewis Fry Richardson a month after the sinking of Titanic, and a German physicist Alexander Behm obtained a patent for an echo sounder in 1913. The Canadian engineer Reginald Fessenden, while working for the Submarine Signal Company in Boston, Massachusetts, built an experimental system beginning in 1912, a system later tested in Boston Harbor, and finally in 1914 from the U.S. revenue cutter Miami on the Grand Banks off Newfoundland. In that test, Fessenden demonstrated depth sounding, underwater communications, Morse code, and echo ranging, detecting an iceberg at a 2-mile (3.2 kilometers) range. 13. The Fessenden oscillator, operated at about 500 Hz frequency, was unable to determine the bearing of the iceberg due to the 3-meter wavelength and the small dimension of the transducer's radiating face, less than 1/3 wavelength in diameter. The 10 Montreal-built British H-class submarines launched in 1915 were equipped with Fessenden oscillators. During World War I, the need to detect submarines prompted more research into the use of sound. The British made early use of underwater listening devices called hydrophones, while the French physicist Paul Langevin, working with a Russian immigrant electrical engineer Konstantin Chalowsky, worked on the development of active sound devices for detecting submarines in 1915. Although piezoelectric and magnetostrictive transducers later superseded the electrostatic transducers they used, this work influenced future designs. Lightweight sound-sensitive plastic film and fiber optics have been used for hydrophones, while terphenyl D and lead magnesium niobate (PMN) have been developed for projectors.